Welcome to Tech Trend Whisperer. Today, we delve into the monumental transformation of Starship, as envisioned by Elon Musk. After Flight 4, SpaceX has implemented over 1,000 significant changes, aiming to make Starship more robust and reliable. Despite the impressive successes, such as the safe landing of both the Super Heavy booster and Starship, challenges remain, and SpaceX is not slowing down. We'll explore the major upgrades, analyze the problems encountered, and look ahead to what the future holds for this groundbreaking rocket. Join us as we uncover the next steps in Elon Musk's ambitious plan to revolutionize space travel. Stay tuned to discover how Starship is evolving and what exciting advancements are on the horizon. In this episode, we discuss the extensive upgrades made to SpaceX's Starship following Flight 4, highlighting over 1,000 significant changes aimed at enhancing robustness and reliability. We review the successful landings of the Super Heavy booster and Starship, address the remaining challenges, and examine the specific issues encountered, such as engine failures and heat shield performance. We also look forward to the future advancements and goals for Starship, including the new design for the hot staging ring, the addition of roll control thrusters, and improvements in engine reliability and heat shield durability. The episode provides insights into Elon Musk's bold vision for the future of space travel and the continuous innovation driving SpaceX's success. Over the past year, Elon Musk and SpaceX have implemented over 1,000 modifications since Flight 1. Despite having 3 flights under its belt and growing stability, the SpaceX team remains unsatisfied. Noteworthy issues continue to persist even after the recent success of Flight 4. Firstly, the vehicle demonstrated stable operation and achieved critical milestones, even though one engine failed immediately after liftoff. This underscores the effectiveness of redundancy. Having 33 engines provides a crucial safety net when one malfunctions. Secondly, the remaining engines exhibited exceptional reliability during both powered flight and shutdown phases. Thirdly, the hot staging ring functions seamlessly in the separation process, smoothly detaching from the booster despite its first use. Additionally, the grid fin and landing engine systems worked flawlessly, enabling a safe ocean landing for the booster. In space, the heat shields outperformed previous flights, ensuring Starship's survival through the harsh re-entry conditions. At the launch pad, numerous upgrades ensured stable system operations with no major issues recorded. These are the significant strides SpaceX achieved with Starship in Flight 4. Maintaining these capabilities in future flights is crucial. However, even more improvements could be realized if SpaceX addresses the issues encountered in the last flight. The continuous pursuit of excellence is what makes SpaceX a leader in space innovation. So, what upgrades will SpaceX need to implement? To answer that, we must first identify the problems encountered in Flight 4. One of the 33 engines failed to ignite after liftoff. Although subsequent steps went smoothly, indicating that the impact was not too significant, SpaceX shouldn't become complacent. The failed engine was in the outer ring, which only operates at the beginning, so it didn't have a major effect. But what if a failure occurs in the middle or inner engines, which play a more critical role in later stages? This highlights the need for continued vigilance and improvement. If engine issues are a recurring problem for the Super Heavy, the heat shield poses an even bigger challenge for the Starship. Despite the heat shield performing well in this flight, its reliability may not yet be at its peak. Many heat shield tiles fell off during flight and were picked up by civilians. This issue compromised the rocket's safety, as evidenced by the flap being burned and severely damaged during re-entry. It's crucial that SpaceX addresses this vulnerability to ensure the integrity of future missions. With these issues in mind, let's outline the changes SpaceX needs to implement moving forward. Firstly, on the Starship, SpaceX will undoubtedly continue to focus on improving the heat shield system. This was confirmed by Elon Musk on X when he responded to everyday astronauts' tweet about the heat shield. Not a difficult prediction, we will have this nailed for the next flight. Clearly, the issue with the fallen heat shield indicates that the connection of the tiles to the Starship requires an upgrade. This commitment to continuous improvement is what drives SpaceX's innovation and success. SpaceX may opt to change the attachment pin system to securely hold the heat shield in place. Additionally, the layout of the heat shield needs modification to provide more comprehensive protection, particularly for parts like the flap, as seen in the recent flight. Furthermore, SpaceX should re-evaluate the materials used for the tiles. Images of the recovered heat shield after the flight show instances of breakage and melting. This is understandable given that the vehicle must withstand temperatures exceeding 1,500 degrees Celsius during re-entry. The meticulous attention to these details reflects SpaceX's commitment to ensuring the safety and durability of their spacecraft. While Starship's heat shield is in better condition compared to NASA's Orion, SpaceX's goal is complete vehicle reuse, including the heat shield. Hence, they must enhance its capabilities to minimize damage, facilitating quick refurbishment for immediate use in subsequent flights. In addition to upgrading the protection system, internal hardware also requires enhancements to prevent issues like those encountered with the recent flap. It's inspiring to see SpaceX pushing the boundaries of technology to achieve reusable spacecraft. Elon Musk mentioned in a tweet about the heat shield, noting that a newer version of Starship has the forward flaps shifted leeward. This will help improve reliability, ease of manufacturing, and payload to orbit. With this upgrade, the flap will be shifted further toward the side without the heat shield system. This adjustment ensures that the connection point between the flap and Starship is more carefully concealed, minimizing direct exposure to the immense energy from reentry. This enhancement significantly increases reliability, and by reducing the impact of reentry, SpaceX can simplify the flap attachments, streamlining production while maintaining flexibility during ship navigation for landing. The innovative solutions SpaceX implements continually push the envelope, setting new standards in the aerospace industry. Another planned upgrade for the Starship is the addition of roll control thrusters and other hardware. This enhancement will help SpaceX better control the landing process and attitude, mitigating issues like valve clogging seen in Flight 3. SpaceX has indicated that they have implemented this upgrade since S-29, and after the success of Flight 4, it is likely they will continue to refine this enhancement in subsequent prototypes. It's exciting to see how these improvements will further stabilize Starship's complex landing maneuvers. For the booster, SpaceX needs to continue improving its engines. In previous upgrades, SpaceX focused on eliminating or simplifying complex and vulnerable parts such as wires and nozzles, which improved engine performance after each flight. However, the necessary reliability has not yet been achieved, so SpaceX must further strengthen its engine improvements. Engine enhancement is an ongoing process that applies to the entire Raptor engine system, from Raptor 1 to Raptor 2 and eventually Raptor 3. Small details will gradually diminish, and some may be eliminated, simplified, or integrated with each other. These optimizations will significantly reduce operational risks, decrease repair and production time, and continue to increase the engine's power. The commitment to continuous improvement is truly commendable and shows SpaceX's dedication to excellence. Regarding the engine issues, SpaceX needs to upgrade the systems within the vehicle, specifically addressing the problem from Flight 3. SpaceX stated that the failure of the B-10 engines was due to a blockage filter in the liquid oxygen path from the fuel tank to the engine, leading to a loss of inlet pressure in the oxygen turbopump engine. SpaceX has upgraded the fuel filtration inside the liquid oxygen tank to address this issue, starting from the B-11 and subsequent prototypes to enhance reliability, particularly in light of the recent engine failure on the 11. They will continue to closely monitor and strengthen these upgrades. It's reassuring to know that SpaceX is proactively tackling these issues to prevent future setbacks. Anticipate a new staging ring design for hot staging in the upcoming flights. Although hot staging wasn't problematic in the recent flight, it still needs modifications. SpaceX aims to create a lighter, simpler, and more efficient ring design. This was evident when the hot staging ring separated from the booster during the last flight, reducing the mass of the B-11. However, this separation will be unnecessary once SpaceX implements the new design. Many eagerly awaited upgrades are on the horizon, each one paving the way for SpaceX and Starship to achieve their future goals. Following successful two-stage landings in the ocean, SpaceX's next target is to land using the Mechazilla arm, beginning with Flight 5 featuring the Super Heavy B-12. With planned comprehensive upgrades for the engine and hot staging, combined with the proven landing capability from the recent flight, SpaceX is determined to validate this new landing method, a feat no other organization has accomplished. In Flight 5, the S-30 will once again splash down into the ocean. The anticipated upgrades to the heat shield and flap will significantly boost the S-30's chances of surviving re-entry intact. This will lay the groundwork for SpaceX to achieve the full reuse of their massive rocket for the first time using the Mechazilla arm. In Flight 6, the challenge will intensify as Chopstick will need to retrieve the Starship from orbit. This task, made possible by the aforementioned upgrades, is crucial for SpaceX to accomplish. Once the rocket's landing is assured, SpaceX will set its sights on venturing even farther into space, whether it's the Moon, Mars, or another celestial body. The heat shield, engine, and flap will all play vital roles in these endeavors. That's all for today's episode of Tech Trend Whisperer. We've explored the remarkable evolution of Starship and the visionary changes spearheaded by Elon Musk. From the successful landings to the upcoming upgrades, SpaceX continues to push the boundaries of space travel. Stay tuned for more updates as we follow Starship's journey toward interplanetary missions. Thanks for watching, And don't forget to like, subscribe, and hit the bell icon to stay updated on all things SpaceX. Until next time, keep looking up and dreaming big.